Alright, so here are the problems on the back of the page. And what do we have? Well, we know the chords are congruent here, so that means that the arc measures are also congruent, so we could set them equal to each other. We know here the arc measures are congruent, so we know that the chords are congruent, so we could set them equal to each other. This one over here is the same thing. This one over here is the same thing. Right. Once we get over to here, the problems get a little bit more complicated. So we have radius is 13, so that means that if we drew this line from here, RP, that would be 13, or also QP is a radius, so that would be also 13. And so how do we find RT? Well, we know that QP is perpendicular to this chord RS, which means it bisects it. Right? That's the property that we went over in the lesson. So that means RT is congruent to TS. And if we know that RS is 12, then we know that RT is half of 12, right? If we know that RS is 24, then we know that RT is half of 24, so that's 12. And then over here, we're looking for QT. So we know that QT is equal to QP, the radius, minus TP. So we need that TP, right? And so again, I drew this little radius here, RP. We know its length is 13 because it's a radius. And then we know RT is 12. So we can find TP by Pythagorean theorem. So I found TP using Pythagorean theorem, which is leg squared plus leg squared is equal to hypotenuse squared. And then what? And then we go ahead and plug it into this equation here, which is TQ is equal to QP, the radius, minus TP. Right? So this entire radius minus TP is equal to QT, or TQ. And yeah, we find that it's 8. So over here, this one's a little tricky because the diagram isn't drawn correctly. Well, it's not drawn accurately. And so what do we know? We know that CD, this arc, is 90 degrees. And if we go back one chapter, then we also know that the inscribed angle, or the central angle, CAD, is also 90 degrees. So if we know that, then this triangle, although it doesn't look like it, is a 45, 45, 90 degree triangle. Right? So then that means that this arc DE is going to be the same as the measure of the angle EAD, which is 45 degrees. So anyhow, there's a couple ways to get to that. Another way to get to that is we have AE is the perpendicular to CD, which means it's a perpendicular bisector of CD. So then CF is congruent to FD. And if that is true, then we know that CFD is half of CD, so it's 4. And we have the diameter is 12. So that means AD is going to be equal to 6, right? Half of the diameter is equal to the radius. So this is 6. And this here is 4. And we are looking for DE. No, I think a better way of doing this is looking at the angle CAD. And if AE splits this chord into 2 equal parts, that means it also splits that angle there, CAD, into 2 equal measures. So since we know that CAD is 90 degrees, then we know that measure of EAD, or is equal to 45 degrees, half of it. And we also know that the arc is the same measure, so it's 45 degrees. Okie dokie. So anyhow, here we're looking for AF. So A and F is this point there. So how can we do that? Well, we can do Pythagorean theorem. So it's AF leg squared plus CF leg squared is equal to AC hypotenuse squared. And we know AF. No, we don't know AF. We know CF because that's half of CD, so it's going to be 4 squared, is equal to CA, we also know, because that's the radius, and radius is half of the diameter, so that's going to be 6 squared. We solve for AF, and we get 2 square root 5. And then lastly, this one down here, what do we know? We know that CD is congruent to CB, and if they're congruent, then that means that these two chords are equidistant from the center of the circle. So we know that GQ is congruent to QE. And if that's true, then we could just set these equations equal to each other and solve for x, 5.5.